Hello, and welcome to Most Significant Bit, the podcast exploring connection between engineering, technology, the arts, and the creative process. I'm Shijin. Today, I want to talk about a vial, more specifically about the role of bombs of vials flipper and how those bombs end up charging way engineer design wind turbine blades and industry fans. The topic today is biomimicry. Biomimicry means looking at something in nature, figuring out how it works, and using the idea to solve a human problem. One of my classmates asked why I picked humpback whale instead of another animal or plant. The honest answer is that the humpback is a contradiction. It's an animal that can weigh around 40 tons, roughly a loaded semi-trunk, and yet it fits by turning in tight circle to trap small fish. It blows spiral of bubble to herd them together. Then banks hard and comes up through the middle. The kind of memory should not be possible at the size, but the researcher want to know how it works, and the answer turned out to be sitting on the front edge of the flippers. So if you look closely at a humpback flipper, the leading edge is not smooth. It carries a row of large round bumps, and those bumps are called tubercles. For most of last century, that would be looked like a mistake. Stand for aerodynamic thinking says the leading edge of a line or blade should be as smooth and clean as possible, because roughness creates dark. This is where the biologist Frank Fish come in. One of my classmates asked me to say more about him and his work at time. Fish is a biology professor at Westchester University who studied how animal moves around water. The story that gets retold is that he saw a sculpture of humpback whale in a shop, noticed that bomb along leading edge, and assumed the artist had put them on the wrong side. When he checked, the artist was right and his own expectation was wrong. The bob really are on the front, being wrong about something he thought he already knew is what started a year of research. What the fish and other research found is that the tropical trends the way water moves across the flipper. As the flow passes over the bombs, it gets channeled into the valley between them and rolls into pairs of spinning vertical. Those verticals carry energy along the surface, and they keep the flow attached to the flipper instead of separating away from it. Attached flow in the whole point. When flow separates from the wing or a blade, you get stall. Life closely and control goes with it. Because the tubercle delays separation, the wire can tilt its flipper at a much steeper angle before anything stalls. Another classmate asked how the connect to turning so dramatically. A tight turn is basically holding a big steep angle without losing your grip of the waiter. A smooth flipping would stall at the angle, and the whole and the wall would slide sideways out of turns. The tubercle flipping keeps working, so a 40 tons animal can carve a circle small enough to trap a school fish. Once you describe it in that way, it stops being about whales. Anything that moves through air or water can stall has some same problem. A company called Wire Power Corporation was built around this idea and applied the geometry to blades. One of the clearest commercial uses high volume, low speed fans. The big slow silent fans you see in warehouse, gym, and barns. Manufacturers such as Environmental System have sold fans using display design, with reported gain of up to about 20% more lift, along with quarter operation and useful airflow at low speeds. A classmate asked which application benefit the most. My answer is fans and turbines rather than aircraft. Airplane wings already absorb an enormous amount of engineering effort, and the certification cost of changing them is high. Fans and turbines run continuously for years, so a few percent of efficiency multiple across thousands of installed units become a serious amount of electricity. I was also asked what other everyday products could use this design. Bubble, leading edge, heavy pin triple or computer cooling fans, HVAC blowers, pump impeller, drum propeller, hydro turbines, and even surfboard fins. And in very efficiency and noise both matter, the idea is the worst thing. So, how much does that actually matters? It is not a revolution. Nobody is claiming that a while doubled the output of wind farm. What I find interesting is smaller and more useful than that, a feature you would never notice on an animal, on that look like an era to train engineers. Turn out to solve problem those engineers were already working on. Then is the part I want to leave you with. Engineering is not always about inventing from scratch. Sometimes it's just we're noticing that nature has already tested something from millions of years, being willing to be wrong about why it looks like the way, and finding a creative way to apply it. Thank you for listening to Most Significant Bits. I'm Shijin Yuan.